Hello friends, welcome once more to class online. My name is Dami, and in this edition we shall be looking at fantastic aspects of physics that will teach you a lot. Don't forget that if you learn something from this video, click on like button. We have a lot to share with you that will better help you understand physics. Now let's get to the question. This is actually what we have is Jamb Physics 2011 question number 11 to 15. Now let's see the questions now. High thermal capacity, high sensitivity, easy readability, accuracy over a wide range of temperature. From the above statement, above, the quantities, these should be qualities of a good thermometer are what? Now, which of them belongs to a good thermometer? Will it have high thermal capacity? Is that true? Or high sensitivity, or high readability, or accuracy over a wide range of temperature? Is it 1, 2, 4, or 2, 3, 4, or 2 and 3, or 1, 2, 3, 4? Do you have any idea? Now the answer is actually simple. A good thermometer must be opaque. That means the liquid in it must be opaque. It must not wear glass. It must be a good contour of it. It must have a regular expansion. It must have a high boiling point and melting point. So that means if it has high boiling point, it must be opaque so that you can read. So readability, like if you have a thermometer, how can you know if a thermometer is good? How can you know if a thermometer is good? If you look at the thermometer, you must be able to read it. Now if it is made of water or alcohol, you might not be able to read it easily. It must be opaque means that it must be colored. The thermometric liquid inside the thermometer must be colored so that you can see it clearly. Like if it is mercury, you can see it clearly. So it should be opaque or readable. Then it must be sensitive to temperature change. Like if you put it in your armpit, it must sense it, right? It must sense that there's a change in temperature. So a good thermometer must be sensible, must be able to sense change in temperature. It must be accurate over a wide range. It must be able to measure wide range of temperature, whether high or low, and that is it. But high thermal capacity is not there. It doesn't have to have high thermal capacity, because thermal capacity is the amount of it needed to raise the temperature of a body by 1 Kelvin. The temperature of the thermometer must not rise. Okay, the temperature of it, that means the thermometer must not be taking temperature away. It must not be reducing temperature. So it doesn't have to have high thermal capacity. It's not true. So that's the answer is just 2, 3, and 4, and that is number 11. Number 12 says a machine is used to lift a load of 20 Newton through a height of 10 meters. If the efficiency of the machine is 40%, how much work is done? Now we have to find work done when we are giving efficiency, right? Now when you hear the word efficiency of machine, this is the formula, and please take note. Efficiency of machine is work output over work input times 100. Full stop. Now we have to find work done. That work done is the work input. So I will turn the formula around. It will give me work input is equal to work output times 100 over efficiency. Okay. Now what's the work output? Force times distance is work. What's the force here? Force, okay, is 20 Newton. It's 20 Newton. Is 20 Newton. Now what's the distance? The distance is what? 10. You know, force and work is force times distance. So I'll be giving the force here and the distance here 10. That becomes 20 times 10 and then times 100 here. Okay, over efficiency. What's the efficiency here? It's 40%. That's 40. That's 20 times 10 times 100. That is actually 20,000 divided by 40, and that's 500 joule. So the answer is simply 500 joule. Please don't forget that efficiency is work output over work input times 100, and that's it. And work itself is actually force times distance. Please don't forget. Keep the formula. It might save you one day in the exam, and that is just it. Now that means D is the answer for number 12. Number 13 says which of the following could be effectively used to reduce friction? Is it water, petrol, kerosene, or grease? Now in this place I have a picture of a man who fell. The man, this man is Mr. Jackson. He fell down because of low friction. He fell down because of low friction, right? Now, which of this liquid made that friction? Now, you will fall down when there's no friction, because friction helps us to walk. Okay, because friction means the force that opposes motion between two bodies. Now in this case we can walk because of friction, because there's a friction between our leg and the floor. There's an opposition between your leg and the floor, but when there's no friction, you will fall down. Okay, now which of them can make you fall by reducing friction? Is it water, petrol, kerosene, or grease? Do you have the answer? That's it. It's actually very simple. It's actually grease. The one that will most reduce friction is things that have to do with oil, and the most oily is not kerosene. That one is like water. Petrol is like water. They are all family of water, but grease has a little bit of oil nature. You know, grease is oil that is what congealed. That means grease is oil. Grease came from oil. That is why grease will make you fall, and that is the answer. Number 14 says a copper wire was subjected to a tensile stress of 17.7 times 10 power 7 Newton per centimeter per meter square. Sorry, calculate the tensile strain, and Young modulus is 1.1 times 10 per 11 Newton per meter square. Now, when you hear the word strain, can you remember anything on strain and stress and Young modulus? That's it. Now, Young modulus is actually stress over strain, right? That means strain is just stress over Young modulus. Finish. This is actually super easy. So, because this topic is all like elasticity, and in elasticity we learn about Young modulus Y as the elastic constant. Young modulus Y is stress over strain. So if you turn the formula around, it becomes strain equals stress over Young modulus. What's the stress? 7.7 times 10 power 7 divided by the Young modulus 1.1 times 10 power 11, right? Now this divided 7.7 divided by 1.1 is 6.9 times 10 power 7 minus 11 is 10 power 7 minus 11, right? And that will give me 6.9 is 7, approximately 7 times 10 power 7 minus 11 is minus 4. So the answer for the strain is 7 times 10 power minus 4. And please don't forget that strain has no unit. Please don't forget that strain is one of the few things in physics that have no unit. It is super important, and the main reason is because strain is extension over length, which are both meter. So meter cancel meter is 0. So there is no unit for strain. Please take note, and the answer is 7.0 times 10 power minus 4, making A the correct answer. Now number 15 says, which is the last one, it says an object weighs 22 kilograms in water and 30 kilograms in air. What is the up thrust or exerted by the liquid on the object? G is 10 meters per second square. Now up thrust is simply when you jump into a swimming pool, there's a force that carry you up. When you go into water suddenly, your weight is acting downward, but there's a push of the water. You will jump in, but the water will carry you first up. Okay, that upward force is called up thrust. Now the up thrust formula is just the weight in air minus the weight in water. Sorry about that, that's a plain person. The weight in air minus the weight in water is up thrust. So the up thrust is weight in air minus weight in the liquid, right? It might be water or another liquid. Now, what's the weight in air? I was not giving weight, I was giving mass. So mass times 10, that's G, will form weight, and that's 30 times 10. Then minus what's the weight in the liquid is 22 times 10, and that is mass times G, right? And that will give me 300 here minus 220 here, and that will give me 80 Newton, and that is my up thrust, making B the correct answer. And that brings us to the end of this video. Don't forget that if you learn something from this video and you want to get more content that will better help you understand, click on like button. We have a lot to share with you that will better help you understand a lot in physics. Until we see again, guys, take care of yourself and bye for now.